In this section, we take a look at access control lists as a mechanism for implementing access control for system resources. Many technologies and protocols depend on access control lists, or ACLs, for greater management and filtering of traffic as part of security measures or application requirements. The implementation of access control lists in support of other technologies and as a form of security are required to be understood, and as such, common forms of access control list solutions are introduced. Upon completion of this section, it is generally expected that trainees will be able to describe the applications for access control lists in the enterprise network, explain the decision-making behavior of access control lists, as well as successfully implement basic and advanced access control lists. We can understand access control lists to be a mechanism that is primarily used to control access to system resources. Rules are defined that may refer to ranges of addresses or other parameters that can be used to group different forms of traffic together. One of the means of control involves operating as a form of traffic filter mechanism that can permit certain forms of traffic to reach certain resources whilst restricting other traffic. This filtering is commonly applied at points at which such traffic congregates, such as the gateway. However, since each packet is to be subjected to such rules, the filtering should occur where the data to be filtered is most concentrated. We show here the existence of two networks in the form of 192.168.1.0/24 and 192.168.2.0/24 and a gateway that is used to control the flow of traffic. In this instance, we can understand that the router is configured to allow traffic originating from 192.168.1.0 to reach the external network, whilst being restricted from accessing certain enterprise resources, such as those represented here by server A. At the same time, traffic originating from the network 192.168.2.0/24 is able to access the resources housed in server A, but has no access to the public network domain. Another means of access control for which access control lists are used is in the filtering of what is known as interesting traffic. We can understand interesting traffic to be data that, once received, will cause some form of response in the form of an action that is taken by that device. We demonstrate here a general example of how interesting traffic generates such a response and takes some form of action. We again have two networks in the form of 192.168.1.0 and 192.168.2.0. The gateway in this instance has been configured to recognize traffic that has a source address in the range of 192.168.2.0 and, where received, is expected to perform the action of encrypting that traffic to secure the contents of the packet over the network. The gateway will therefore need to inspect the packet source addresses in order to discover packets originating from the 192.168.2.0 network. For all other traffic, it will be transmitted without any further action taken by the access control list. VRP used within ARG3 series routers is capable of supporting three types of access control lists. These are referred to as basic, advanced, and layer 2 access control lists. Each access control list is also associated with a value range, and by configuring an access control list in a certain value range, the type of access control list will be determined. For basic access control lists, the value ranges from 2000 through to 2999. For advanced access control lists, the range is from 3000 to 3999, and for layer 2 access control lists, the range is from 4000 through to 4999. Each access control list is able to filter based on certain parameters that will identify traffic and take the relevant action. As we can see, the basic access control list will only filter based on the source IP address, whilst advanced access control lists filter based on parameters including the source and destination IP addresses, protocol types, and source and destination port numbers. For layer 2 access control lists, filtering is performed based on the MAC addresses. Access control list rules are used as a means of determining whether an action is taken based on the parameters that are specific to the access control list type, as we have just seen. Rules are subject to an order of processing that is known as a matching order. The matching order of rules can be supported by one of two methods. The automatic order structures the rule order based on what is effectively a depth-first principle. This means that the more accurate rules are matched first, for which a more accurate rule can be understood as having stricter matching conditions. The default matching order, however, is the configuration order that allows rules to be matched based on the ascending order of rule IDs. As we can see from the example, rule IDs are created as part of each rule, and rules are matched starting from the smallest rule ID. If rule IDs are not configured for each command, they will be assigned based on a step order, which by default is set as 5. This means that, as we see in this example, each rule is configured with a rule ID in increments of 5. The example itself is based on a basic access control list, as can be understood from the value of 2000 that is part of the basic ACL range. We find that there are two networks, in the form of 172.16.0.0/24 and 172.16.1.0/24, that will be subjected to the ACL rules as packets traverse the gateway of RTA. Rule matching order will begin with Rule 5, and where rules do not match, the next rule will be assessed. Rules that match a deny clause will be dropped, and where they match a permit clause, they will be forwarded without further action. We find, however, that the first two rules match only 192.168.1.0 and 192.168.2.0 networks. This is followed by a wildcard mask that determines that, as with OSPF network advertisements, the first 3 octets must be fixed, and the remaining 8 bits in the last octet can be of any value. Rule 15 involves a deny statement that denies hosts in the 172.16.0.0 network, where the first 3 octets are fixed as 172.16.0. This means that traffic from the range 172.16.0.0/24 will be denied, but packets from the 172.16.1.0/24 network will not be matched. Rules without a match will not be subjected to the access control list, and in the case of packets from 172.16.1.0 hosts, these will be forwarded. In the interest of good design practice, however, it is generally recommended that a catch-all rule be included, which we see here in the form of Rule 20, that permits all other packets regardless of their source address. One final thing to note is in the order of the statements, particularly in that deny statements are generally implemented before permit statements, to ensure that any packets that are denied are not firstly matched to a rule that permits the same packets to be forwarded. We now take a look at some examples of how the various access control list types may be implemented, beginning with the basic access control list that, as we have shown, performs rule matching based on the source IP address of packets. We are currently dealing with two hosts in the form of host A and host B that exist in the respective networks of 192.168.1.0/24 and 192.168.2.0/24. We are expected to restrict any traffic originating from the 192.168.1.0/24 network, which includes host A, from being forwarded via the interface Gigabit Ethernet 0/0/0, whilst allowing traffic from the 192.168.2.0/24 network to flow freely. The configuration requires that the access control list be created based on a number in the relevant range. Here we are using the first number in the basic access control list range of 2000. Next we configure the rule statements that are to be used to assess the traffic. We begin by configuring the deny clause, which here is set to restrict traffic originating from the 192.168.1 network, which is then followed by a permit statement to allow traffic originating from hosts in the 192.168.2 network to be forwarded. We will also notice that the rule IDs have not been created for the rules here, and so the default rule IDs will be implemented based on the step order, which by default is set to assign rule IDs in increments of 5. Following the configuration of statements, we must enter the interface view for interface Gigabit Ethernet 0/0/0 to which the ACL is to be bound, at which point we will use the command traffic filter outbound to apply the filter for traffic being forwarded out of interface Gigabit Ethernet 0/0/0 and associated with access control list 2000. We can attempt to validate the results of the implemented access control list by attempting to send ICMP packets to the intended destination from hosts in the restricted address range, which in this case includes host A. If we attempt to reach the location of 200.10.10.1 in the public domain, we will find that our requests from host A are timing out. We can then use the command display ACL 2000 to view the rules configured. We will find that the two rules that we have configured are listed here, along with the step order that is supported. In the case of Rule 5, we find that the rule shows 5 matches, which demonstrates that the access control list has matched the ICMP packets sent as part of the ping to 200.10.10.1 and discarded these packets before they could be forwarded out of interface Gigabit Ethernet 0/0/0, resulting in the request timeout occurring. With advanced access control lists, there are a larger range of parameters that allow for a much greater level of accuracy to be applied to rules. However, this also adds complexity to the ACL itself. We demonstrate here the configuration of an advanced access control list that again looks to apply filtering to the 192.168.1.0 and 192.168.2.0 networks. In this instance, however, we wish to ensure that TCP-based traffic originating from the 192.168.1.0 network, destined for the IP address of 172.16.10.1, and where the destination port number in the TCP header is 21, be restricted. Additionally, we also wish to restrict all IP packets originating from network 192.168.2.0/24, but only where packets are destined for the address of 172.16.10.2. We apply the traffic filter command on the inbound interface of Gigabit Ethernet 0/0/1, so that filtering is limited to only traffic being received over this interface, to which the advanced ACL rules are then applied. We can again return to the display ACL command to view the results of the configuration for Advanced Access Control List 3000, where we find the two rules have been applied, demonstrating that the rules have been configured. We find in the instance of Rule 5 that the destination port equal to 21 is shown as FTP, since port 21 is recognized as the well-known port number for this application layer protocol. Since no traffic has yet been forwarded, there are currently no matches displayed. As we may have observed, the application of access control lists represents an important part of the implementation of network address translation. It is used primarily for determining the interesting traffic, that is to be identified as data originating in a private network that is to be translated using public addressing, before being forwarded over the public network domain. We demonstrate in this example the role that the access control list plays in supporting this filtering of interesting traffic for address translation. The example shows two address groups that have been created that supports two pools of public addresses, in the form of address group 1 and address group 2. Additionally, we find that two basic access control lists have been created in the form of ACL 2000 and ACL 2001. ACL 2000 in this instance has been used to identify packets originating in the network 192.168.1.0/24 and associate these packets with address group 1, as we can see from the NAT outbound 2000 address group 1 command applied to interface Gigabit Ethernet 0/0/0. This means that for data originating from hosts in the 192.168.1.0/24 network, these packets will be assigned public addresses from address group 1, which supports the public address range from 202.110.10.8 through to 202.110.10.15. For hosts in the 192.168.2.0/24 network associated with ACL 2001, the same process is applied. However, packets originating from hosts in this range will be assigned public addresses based on address group 2, in the range of 202.115.60.1 through to 202.115.60.30. So in summary for this section on access control list, we have just a couple of questions here. The first asks, the advanced access control list is capable of filtering traffic based on which attributes? Well, it is capable of filtering based on the source and destination IP addresses, source and destination port numbers, protocols of both the network and transport layers, as well as other parameters such as the IP traffic classifiers that are used for prioritizing traffic, and also TCP flag values such as the SYN and ACK bits. Once an ACL rule is matched to a condition, what action is taken? Well, if the condition matches an ACL rule, the rule is applied based on the action listed, commonly as permit or deny. Once an action has been applied to a tested condition, the ACL process will cease to continue.